Hello everyone, this is Pamper Chew. Today I'm going to finally replace the battery, the CMOS battery, in this Compaq SLT286. This is a laptop from 1988 and it works just fine, except for it does not have a working battery on the CMOS, and it is kind of needed for it to function properly without having to reload the BIOS every single time with the custom settings. Settings like the time and the fact that there's a hard drive in here, or the fact that this is a high density double-sided floppy drive. It won't work unless that is loaded into the CMOS. So here's a diagnostic disk, which is used for programming the CMOS. And then the battery, since it's a NVRAM, it's a battery inside of a chip, and the battery doesn't last, maybe 15 years at the most, and this is 30 some years old. So I'm going to go ahead and replace that chip. And for this laptop, it's a little more complex than just swapping out the chip, because it is soldered to the motherboard. Actually, let me get a shot of it turning on first before I take it apart. Okay, so I have it plugged in now. There's a power supply for it, and it plugs into the side here, and the power switch is right here. So there it goes. It's not making any noise, which is kind of unusual. It should at least have a hard drive sound. I don't think the hard drive is spinning at all. There it goes. So here's basically the BIOS screen. The last thing I've modified on this is what was adding the coprocessor, the math coprocessor, which is an 8287. And that's about it. I had taken it apart a couple years ago to tackle this problem about replacing the battery for the chip. And at the time I just didn't have the tools or the knowledge to do this kind of soldering. So I'm going to take it apart now and take a look at the motherboard. Okay, here's the computer outside of the case. This just pulls right out after disconnecting the keyboard and monitor from the video cable that goes there. So this is where the monitor connected to, and the PS2 keyboard went in there. So from here, I guess I can show you around the computer parts before I dig into it deeper. This piece comes off, it's socketed, And this is the ISA expansion bus, and I happen to have some of the memory modules that plug right into there. But yeah, that's the ISA expansion bus, and these are memory. Now I think I have to remove the screws around the outside, and this should come apart so I can get to the motherboard. Okay, so I took out the memory, some screws on the side, the little screws that hold the plugs on there, and the modem. This is a modem, and it needs to be unplugged, and also the hard drive connector right here. Okay, next step. I think I need to remove the power supply also. Maybe not. One more screw there. Alright, here's the motherboard. And I can take a look around. This is the main memory here that most people that have this laptop, this is usually the only memory that they have. Where mine did come with the extra 2 sticks here. And there's also a third type of memory called the piggyback. And that plugs in somewhere over here also, but I don't know how. But it's like a card that plugs in and it's flat. I don't have that one on here, but that is a more common option for the expanded memory. Okay, so over here is the 8286, and this is the 8287 that I put in, and the rest of the chipset. This would be for the video memory. Here are the EEPROMs, and this is the CMOS. I mean, it's the BIOS. So this would store information that's basically what it was loading without the diagnostic discs. It's loading the default information. This is an EEPROM, which is it's erasable, but it's not usually erasable in the way that you can just go on a computer and write over it and erase it and write over it. You have to take it out of the socket and put it in a special box with the UV light that shines into it and erases it that way. It takes about 10 to 20 minutes. So it's not like I can't just update these from software. This you can. Now this is a little bit of memory. It's SRAM, which is battery backed by a battery which is inside of this chip. And so this does, for one thing, it keeps time. Okay, and the other thing it does is keep all the little configuration settings you have, such as I have a hard drive on this connector and I want you to boot from this hard drive, or in this case the floppy drive only works in 720K mode, although it can read 1.44 megabyte floppies once this is updated with the diagnostics disk. So this is what I need to do. I need to remove this chip, and I was going to put a socket in. Like these are socketed here. This is not socketed, but I want to make it socketed so that I can either replace it with a modified real-time clock, because the battery is internal. It's not easily replaced, and they don't make them anymore. So even if I do have one of these that'll work in here with a good battery, it might not last more than 10 years. And so a lot of people have modified the chip itself by dremeling into it and finding the battery terminals and just having an external battery onto the original chip. But what I'm going to do is I'm just going to make it socketed. I'm going to desolder this battery, take it out, and I'll do that. Okay, so this is the challenge, and that's replacing that chip with a socket. Now, it was more like 4 years ago when I first took it apart to see what I would have to do, and this was a extremely difficult job I would have to do at the time. It was something I hadn't been experienced with enough to want to go ahead and attempt on this board. Well, now I do have that experience, and I can definitely do this. It's a very easy thing to do. It looks a little intimidating, I guess, at first, because that's what I felt 4 years ago, but now it's no big deal. So I'm going to remove that chip now with a hot air tool, and find a nice socket that'll take its place. One more thing I wanted to add here was that there is a thickness decided. I mean, that's how they built this, probably was by what was the thickest part, and that's how high they made these little standoffs. Well, the thickest part on this board are going to be those EPROMs up front, and those are socketed. So maybe that's why they didn't put a socket on the real-time clock, was because it's already that high, and by adding a socket would require the laptop to be just that much thicker. And well, it's already pretty thick. I don't know if they really were trying to make it thin as possible, but it sure looks like that's why they did not socket it, because that's about the same height. So I have a little bit of clearance, and if I cannot find a thin enough socket, there's kind of a minimum depth that they have. I could also cut out a hole where the chip can go so that it's also accessible from the outside. And I'll probably do that. Just cut a hole right here where that chip is. And that way, after I put it back together, I never have to take it all the way apart just to replace that chip. And I really don't mind modifying my hardware. It's not really like it's a big deal. Even though it's rare, it's still, I want to use it, and that's just an improvement. So I'm going to start doing the board, getting the chip off. Okay, so I masked off the area with Kapton tape, and then I even outlined it with some of this black insulating tape. It's kind of like Kapton tape, just so I can see it, because it's very hard for me to see the tape there. And this is the set of pins that I need to, I'm going to try it a few different ways. The first thing I'm going to do is add solder to all the pins and try sucking it out or using a solder wick. And if that doesn't work easily, then I will go ahead and use the hot air tool and just heat up the whole area and let the chip fall out that way. So this is the solder that I'm using. Made in Oregon. For, looks like an audio company. But this contains silver. It's silver solder. And this is the stuff that I recommend getting. It doesn't cost too much more than regular solder, but it does cost a little bit more, and that's because of the silver content. But the old electronics, even new electronics, this is so much easier to use than lead-free stuff. Okay, so after removing as much solder as I could with the solder wick, I used the hot air tool to just heat up the rest, and started pulling at one side while I was heating up one side, and both sides came out. It looks like it might have been glued on. There's the battery. There's the spot where it went, and it doesn't look like I disturbed anything. So now I'm just going to clean up this section and go see what's on here. And probably nothing, because it's blank, because the battery died. But still curious, and I'll find a replacement part in my stuff, because I know I have a few of these, different sizes, different models, but the Dallas time clock. Alright, this is the socket style I'm going to use. It's a little bit longer than what I need, but I'm just going to cut off the end there from that bracket and over, so that way it can sit in there. Actually, I found a better chip socket that'll fit here. Alright, so this is the chip socket that I'm replacing where the chip went. It just drops in like that. And then the EPROM, or I mean the CMOS, the Dallas time real-time clock will go right into that. This is the lowest profile socket I could find, but it should work just fine. And there it is, all done and cleaned up. So this is the socket that the chip will go in, and the final height will be just a bit taller. There. Alright, now I'm going to go find a good Dallas DS1287, or I will modify this one and make this one work. So here's the part that needs to be cut out of this metal plate. Just an area right around there for the chip to poke through. Once it's all reassembled, that way it can be replaced without having to take apart the computer at all. Just underneath the keyboard will be the socket for the memory. So in the future, if they ever do start making those chips again, or if I find a good one or something like that, I can just easily swap it out. And it makes it easier for modifying stuff and trying out different ways of hacking the thing. Alright, I drilled some holes into the area I needed to cut away, and now I just need to finish it up by clipping off these side pieces and then filing it down to make it nice looking and square. Alright, there's the hole. It's square enough for now. I just used a file to trim out the edges. Let's see how close I was to guessing it. Perfect. They're just about perfect. I might make that one section there. Actually, you know, it's fine. This is good. I don't need to keep modifying it, but I did want to have at least some room for getting a tool in there. Now it looks like it'll work just like that. Alright, now to put it all back together. And here it is starting up again with the modified real-time clock socket. So it looks like I didn't destroy anything. Let's make sure the drive works. Okay, so I had a spare chip in my stuff that I had already started to modify. Here it is. I took a battery out of a laptop, IBM laptop or something. What is it, like 4 in the morning? Okay, looks like it set up the modem and serial device automatically. And then I just need to go over, so it's going to set the floppy drive up so that it can read 1.44 megabyte drives or disks, and it has set up the hard drive, which is a Type 22. I can go F3. Oh, exit F4. Here's configuration settings, the coprocessor, video adapter, screen save. Oh, it's a built-in screensaver. Power on, operating speed. High or fast? Which one's better? Fast. But fast might be slower. That's high speed or fast speed? What's faster, high speed or high speed or fast speed?
I think fast speed.
Okay. They should just say high or low or something. It's the same thing with USB. Full speed or high speed or double density. Anyway, before I mess this up even further, let's just save it. Exit and save changes. Now what I'm going to try doing next is disconnecting the power. Once I know that it boots up, I'm going to disconnect the power, wait like a minute, and then plug it back in to see if it still has the time and the settings. Whoa, it beeped once, so it definitely has the time. Okay, I'll shut it off. Disconnect power. Now the only thing keeping time is that little battery. Okay. It should be cleared enough. Yeah, it works. So now it has time. I can type in time, and there it is. And I will set the correct time later. Date. What's the command for date?
In Windows?
Yeah. Oh, DATE. I hit data. There you go. And there is the current date, 2019. So even this is Y2K compliant.
Yeah, it's doing its thing. Can you see it?
Yeah, the plant is happy now. F takes him to the fair, if you're in the living room. Z. He has to load. Donald Duck has to load. There he is.
Ooh, it's weird.
Well, yeah, the screen. You can't even see it in the... We should hook the monitor up to this thing. Since this has color graphics and output for color graphics, there's the port there, but modern cables, or the modern analog cable, has all the pins there, and the older plugs had one pin blocked. And I had to do this with my monitors, and that is drill out a little hole so that I can plug in a regular cable. And that's what I'm going to do here. because it's really annoying to have to clip the pin off of each cable. And that's it. Look closely, you can see the little pin underneath. So now, I should be able to plug in my regular cable without interfering. There we go.